Today we're going to start Chapter 7, which is a chapter on polynomial functions. And this chapter is going to provide you a lot of the fundamentals of what you're going to need for future math classes. So this is going to have a lot of stuff in it, and we're just going to keep building off of it, so get ready. Okay? Today we're going to start in Section 1, which is polynomial functions. And if you remember back to Chapter 5, we talked about polynomials and monomials. But today we're going to talk about polynomials in one variable, which a polynomial in one variable means that it only contains one variable. It's only allowed to have one letter throughout the entire polynomial. Okay? As well with our definition of polynomials, it has to have positive integer exponents. You can't have any fraction exponents, and you cannot have any negative exponents. That means that you can't have any variables in the denominator, or you cannot have any variables underneath a radical. Okay? And then all the coefficients are real, so no imaginary numbers here. Okay? The degree of a polynomial in one variable is going to be the greatest exponent. So if you're looking at a polynomial, the one with the biggest exponent is going to be the degree of the whole polynomial. And then the leading coefficient is the coefficient of the term with the highest degree. So that term that you looked at to get the degree of the function, you're going to look at the coefficient of that term. The coefficient means the number in front. You're going to look at the coefficient of that term, and that will be your leading coefficient. Okay, so for example here, we have g of x equals 2x cubed minus 4x to the fourth plus 7. Okay, this is a polynomial because here we have all positive integer exponents. We only have one variable, and all of our coefficients are real. So this is a polynomial. The degree, we're going to look for the biggest exponent, which is 4, so we have a degree 4, and then we stay at this term, and the leading coefficient is the number, including the sign, out in front. So this has a leading coefficient of negative 4. Okay, right here we have f of x equals 1/2 y squared minus 2 divided by y plus 1. Okay, this 1/2 is actually okay because that's a real coefficient. However, we have an issue here because this would be a y with a negative 1 exponent. We can only have positive integer exponents. So here, this term right here makes this not allowable to be a polynomial. Okay? Alright, so let's try some examples. First, we want to state if this is a polynomial in one variable, and if so, I want to state the degree and the leading coefficient. Okay, so we can only have degree and leading coefficient if it is a polynomial. So, 7x to the fifth minus 3x cubed plus 2x. Let's check, do we only have one variable? Yes, we're only dealing with x's. Are all of our exponents positive integers? Yes. And are all of our coefficients real? Yes, this one is a polynomial. Okay, since it is a polynomial, then we have to decide our degree and also our leading coefficient. Okay, so the degree is going to be the biggest exponent. This has an exponent of 1, 3, and 5. 5 is our biggest exponent, so the whole polynomial takes on degree 5. Okay, and then we stay with this term with our biggest exponent, and the coefficient out in front, or the number in front, which is a 7, becomes our leading coefficient. Okay? Right here we have negative 3/4 x to the 6th plus 2x to the 4th minus 17/3 x squared minus 1. Do we all have one variable? Yes, we only have x's. All of our exponents are positive integers, and all of our coefficients are real numbers. We have no imaginary numbers. So this is a polynomial. Okay, which means that we're also going to be looking for the degree and the leading coefficient. So degree, again, we go through and look at all the exponents, and the one with the biggest exponent makes that the degree for the whole polynomial. So this polynomial has degree 6. We stay with that same term, and the number out front is our leading coefficient. So here our leading coefficient is negative 3/4. Over here, we have 8x squared minus 2xy plus 9. Is this a polynomial? No, this is not a polynomial in one variable. Okay, that's what we're dealing with in this chapter, polynomials in one variable. Here we have this y, and we also have these x's. So this is not a polynomial. No. So since it's not a polynomial, we don't have to decide degree or leading coefficient. This one, we have the square root of x minus x squared plus 4. Okay, this one we only have one variable, which is good. All of our coefficients are in fact real numbers, but the issue here is exponents having positive integer exponents. Because here, if you remember, the square root of x is actually x to the 1/2 power. So this little guy right here is going to make this not a polynomial. Okay? And that's our polynomials. Alright, so on to evaluating polynomial functions. Okay, here we're going to have our function notation f of x. This does not mean f times x. It means you're evaluating a function at, oops, this should be r, of r. So here this variable always matches the variable in the problem. So we're going to have f, the function f evaluated at r. So we have all those r's. Okay, so if f of r equals 3r squared minus r plus 2, find f of 5. This means that we are finding the value of the function when r equals 5. So if you see here, we replaced r with a 5. That means we're going to do that everywhere we see an r. So there's an r here, so we put a 5 there. There's an r here, we put a 5 there. Okay? Then, to evaluate it, all we do is simplify the right side. Okay, you leave this left side alone because you're telling the person who's looking at what you're doing that you're evaluating the function at 5. You don't solve for f. We just leave it f of 5. And then we simplify this side. So using order of operations, we take our exponent first. So 5 squared is 25. Then 3 times 25 is 75. Minus 5 plus 2 is going to give you 72. Okay? Here with our g of x, if g of x equals negative x squared plus 6, find g of negative 4. Okay, so wherever I see an x, I'm going to plug in that negative 4. So I'm going to have a negative 4 squared plus 6. Okay, and then my job is to simplify this right side only. So using order of operations, I want to do my exponent first. So negative 4 squared, negative 4 times negative 4 is positive 16 plus 6. And this negative is on the outside of the parentheses, which is basically being multiplied by negative 1. So now I'm going to have this negative 16 plus 6, which is going to give me negative 10. And that is your g of negative 4. Over here we have h of x equals 2x cubed minus 4x plus 1. Find h of negative 2. So wherever I see an x, I'm going to plug in a negative 2. So I will have negative 2 cubed minus 4 times negative 2 plus 1. Order of operations, I want to deal with exponents first. Negative 2 cubed. Negative 2 times negative 2 is positive 4 times negative 2 is negative 8. So I'm going to have 2 times negative 8 minus 4 times negative 2 plus 1. Then we do multiplication, so 2 times negative 8 is negative 16. Then I have a minus 4 times a minus 2, which is going to give me positive 8 plus 1. Negative 16 plus 8 is negative 8 plus 1 is negative 7. Okay? We're going to stay in section 7 for 3 days, so this is part 1, and stay tuned for part 2 and 3.